we've reached new levels of Damie instantly blasts everyone with demonic noise. You know, we had to get like the weak people out of the way. That's what I always say. Sorry guys. I'm really tired. I've genuinely been studying math for like 6 hours today. There's some stuff I need to do. I was planning on lecturing. We're not really gonna lecture because I don't have time for that. We're gonna do this and then we're gonna do some physics. And then I need to shower and then I need to go to bed. Because yeah, shit's hard. One fun thing, I was playing around with mouth tracking, so hopefully my mouth tracking is a little bit more responsive. Because I speak in a little voice a lot of the time, and I keep looking over at this monitor, so if you see me looking over this way, that's why. But yeah, let's do this. Okay, let me write out what I need to do. Okay, so first, we need to do... what would be good to do first? Let's do phase portraits. Portraits. Then we'll do method undetermined coefficients, because I need to do some of those. And honestly, that's all I think I need to do for math. I'm just gonna leave this up over here so I don't forget it. Don't let me forget it, chat. Okay. Phase portraits. Basically, I'm not gonna even really attempt to like explain this because I don't want to like confuse you guys too much. Basically, we're gonna be drawing some cool little portraits based off of some matrices of systems, right? So we've been solving matrices based off of linear equations, but we want to solve them based off of systems of differential equations instead of linear ones. So it's not really going to make much sense, but so there are 3 different types of cases. We can have real eigenvalues, we can have pure imaginary eigenvalues, and then we can have dirty, no, I don't know, just imaginary. Okay, so we'll start with the first case. Within that first case, there are a couple cases. So we're only doing these for a 2x2 matrix, which means that at most it's going to have 2 eigenvalues. So we can have mixed, so that's positive, negative. And that's going to look like this. So we have our little drawing here. We're going to have one line that goes like, I don't know. Doesn't really matter. But one is going to go out and one is going to go in. So this one is the positive and this one is the negative. And it's going to look like this. Our solutions, they're going to kind of follow these in little curvy boys. And this is called a saddle point. So that's one kind of system we can have. The next one is if they're both positive. This is, you can kind of imagine what this is going to look like. So we'll have 2 eigenvectors. We can use the same kind of thing. But instead of both pointing at, one pointing out and in, they're both going to point out. And now you're like, Damie, what the hell? This is so weird. What is this? Well, they're just gonna point out from these boys. Like this. Well, that didn't work out too well, huh? What did I skip? I skipped one. Oh, fuck. Okay, well, they'll point out from these lines. Whoopsies, I did these ones wrong. Like that. And this is called an unstable node. because the center is the node, and wherever you put the wherever you put the point, like if you put the point over here, it's going to kind of go over this way. And it's always going to go away from that. The other case we can have is if they're both negative. This is confusing. That's going to look like this. We're going to have our same thing, but this time these are both going to face inward. Because that, the e to the lambda t, which is defining our solutions for these, this is going to be negative because lambda is negative. So that means it's going to decay. It means wherever we put it, it's going to kind of come into the... Did I fuck it up again? I think I might have fucked it up again. I did, that's wrong. Should go into these like that. Wait, fuck, wait. Into this one like this. Into this one like this. And then into this one. And that's called a stable node, because wherever we put the point, it's gonna pull in towards the center. Okay, so that's all the cases for the real. Well, it's actually not all the cases for the real. We can have a defective lambda. And if we have a defective lambda, don't actually know what we do in that case, so we gotta look at what happens in that case. What happens for a defective lambda? So for a defective lambda, well, we can at least kind of start drawing this. Okay, so for a defective lambda, that means we're only going to have lambda, lambda equals, or so let's say lambda is positive. Means we're only going to have one eigenvalue with multiplicity 2. It can't be complex because complex always come in conjugates, so it'll be positive or negative. It'll be a real value. So if lambda is positive, our defective case kind of looks like c1 e to the lambda t times some vector plus c2 e to the t e to the lambda t times some other vector. It actually doesn't look exactly like that. c2 e to the t... Oh, no, wait, that's not it. Yes, it is. No, it's not. This comes out in front. Oh, I can write it like this. Sure, we'll do that. Plus e to the lambda t times different vector. We'll just say it's 1, 0. Could just be anything. And then plus c2 times t e to the lambda t of the first vector. So if we think about it, in this case, we definitely know it's gonna be unstable. So it's unstable something because it's exponentially growing, but it's a good question of what it looks like. So let's take a look. Okay. So it's going to go out from this line because this line exists. This is our first. It's our eigenvector that we have because we only have one eigenvector. This is in our Jordan normal form. We'll have some a, and then a 1 up here. And if we were to get the eigenvalues of the vectors of the matrix, what would they look like? Well, it would have to be the one that we chose. What? No. Huh. Do I know how to do that? I think you have to plug it back in. So there would only be one eigenvector, and then it would kind of like go, it would kind of loop away like this, because of the this over here, the t e to the t. So it kind of like goes out from this point. And this is called a degenerate node. So unstable degenerate node, I believe. And if it's negative, then we're gonna have a stable. We like negative things. Still a degenerate node. Because we only have, it's like, there's only one, like there's a weird line here. I should make a note that these are, oh shit, this one goes in, sorry. I always draw them out like that because I feel like they're nicer that way, but not the case. Oh, and I guess it might be clockwise or counterclockwise, depending on... Like, could they come... Well, I guess they couldn't really come over that way, so it doesn't really make any sense that it would be the other way. Okay, so we got those. We've got... So that's all the real... all the real possible lambdas. Every one of them. That's covered. Which is kind of nice. No more, no less. So now we can do the imaginaries. Your imaginary lambda is our, it's gonna be lambda equals I. Wait, how can you have a one that's not like this? A equals A times I. Wait a second. You can only have one eigenvalue and then... Sorry, wait a second. Oh, I see. So if a generic, sorry, I'm reading this little thing. Oh, if lambda 2 is less than lambda 1 is less than 0. What the hell? I'll have to do some examples. But these might not be the way of writing it. I don't see how you can only get... Since both lambda 1 and lambda 2 are negative, the limit equals... of the whole thing equals 0. So that, yeah, as they, okay, sure. Using the fact that lambda 2 minus lambda 1 is less than or equal to 0, we can see that for large T, oh. So the bigger eigenvalue will be Right, V1 is the... Yeah, okay. Whoa, what? Oh, I guess... Okay, I get it. Let me... So it's not... Okay. Okay. There's no second eigenvalue. That's kind of silly goofy. Okay. So then it's just like this. Right? Let me... Oh god, dear lord. Figuring this out together, chat. Okay, so this is V with lambda closer V4 closer to 0. And if they're both negative, then let's see. I'm gonna be so happy when I can sleep, chat. When I don't have to do this class anymore and I can sleep. And also I can... Oh wait, shit. If it's both positive, then I think it's the same thing. Wait a second, which one would be larger? V1 minus 2 is greater than or equal to 0. So in this case, for positive, the one that's bigger will still be lambda 1. So it's the one that's more positive, I guess. Cool. Okay. That's a little confusing. Wait, so... Oh, I see. Okay, so for the defective case, they kind of spiral around because we have the e to the t, e to the t. Spirals from t, e to the t. Okay, so for pure imaginary, I think the only case is, wait, let's see. So if it's defective and it's not equal to 0, if it's a scalar multiple of the identity matrix, then if lambda is less than 0, then they approach. If it's... Okay. So... lambda negative... is a stable proper node? Yes. This is A equals C times IN. Or lambda times IN. Wow, it's so interesting that like positive things are unstable. I feel like we so often think of as negative as like a bad thing or like an uncommon thing, but truly negatives and complex things are so much more common in differential equations. In terms of stability and, yeah, just stable systems in general. Which I think is very cool. But it has to do with exponential growth. Like, you don't want matching frequencies. You don't want, like, you don't want exponential growth. Egg is not a stable system. It's okay, you could be stable if you wanted to. Okay, so we did pure imaginary. Those are our proper nodes. If it's not, then it is defective. Yep. So we did that already. My mic really wants to spit out absolute dog shit today. I'm sorry for that. It's like the third time that's happened. A heap tree. I don't know what a heap tree is. Let's see. Let me see if I actually do know what a heap tree is. Is it, oh. Continue without support. Let's see. Oh, is it just like a binary tree? What is a heap tree? As heaps are stored in the form of linear data structures, they can be traversed. As is, on the other hand, they can perform different traversals. Okay. So it's just a tree. Like, you kind of have, I know a little bit about it. Oh, heap sort? I'm not sure. Not sure how heap sort. But the idea between a tree, right, is you have like nodes, which is funny because we're also talking about nodes for this. You just have a bunch of things that are connected, and you can recursively move through these things, you know, to find different information that you may want to find. So by like, it's sort of like a linked list, but just in a different visualization. Like you can only have, well, I guess you could have multiple leaves coming off of, I think you can have, I mean, most of the ones I know have just two, but that's what a heap tree is. And then a heap just is, I think, referring to the way in which you can traverse. Oh, I know why it's doing this. I almost never have my headphones on when I stream, and that's why it's fucking up so much. Okay. Yeah, let's try and not power limit my computer. Heap looks just like, honestly, I mean, I did heaps, I think. But yeah, I don't know enough to know how to do a sort. It's been a long time since I took data structures. By long time, I mean like the year before last, but like in my brain, it's a very long time. The last case we do have to mention is just regular imaginary. So A plus or minus bi. These are where we'll get circles, or we'll get points. So if we have okay, if a equals 0, we'll get circles, because this will just be our, we can kind of think about it like in terms of what we'll be getting in the E. So this will, if we just have 0, this will be e to like the I, and then that'll turn into just like cos plus I sine. But if we have e to the a plus bi, we'll get e to the at times cos plus I sine. So for a equals 0, we'll just get circles. And I think, or yeah, circles or ellipses. And so ellipses. This is a stable center. Stable center. And then B is, or A is greater than 0. Or I've been doing A is less than 0 first a lot. Then we have an unstable spiral. And sometimes this can be called like a spiral sink. Yeah, this is an unstable... Wait, sorry, this is the stable one. Stable spiral point. Check direction from E lambda. And then we'll get an unstable spiral point if A is greater than 0. That's when we go out. And these are log curves. If anyone is interested. I mean, honestly, it's late, Damie. You know, I haven't explained any of this shit. It probably looks like crazy nonsense. Unstable spiral point. But this is very useful for me and also my classmates, and I'm going to send this on a Discord right now, actually. Let me just plop this in my Discord here. That and this. Oops, I don't need to. I can get rid of this stuff. And then just wait, select everything, unselect, riveting content. That's my streamer. My streamer, he's selecting content and then putting it into Discord. I love my streamers. POV, you survived the Damie reviews for finals stream. If I was a big enough streamer where I could make those like little badges or whatever, y'all will get a little badge. Okay, we're putting this in the... the other one too. Okay, we stay winning. Hi, Rev. Oh my god, it's late for you. Oh, it's not that late, I guess. I have finals at 7 a.m. tomorrow. Well, I didn't need to cram. I mean, I already did a lot of my cramming for this one, but I need to. I'm probably gonna actually cram for chem. I'm worried for chem, guys. Maybe we'll just like do. Should I just like say fuck it, we ball and just do basic ass chem on stream? Not that late, it's summer for me. You poor thing. I start like basically October though for school, so you know, it's a trade-off. Like I basically get here like the 28th. Classes don't start till like right around my birthday, so it's like it's shifted over a month. I get out like a month later than everybody else, or a little bit later, so. I know, right? Quarter system goes crazy. Okay, let me do some practice. Okay, we get real lambdas. We get both mixed, that's a saddle point. We get both of them positive, that is unstable. Node. Hell yeah. And his negative is like a birthday gift for you, more class. Actually, my classes next quarter are gonna be kind of exciting, I think. I'm gonna have lots of mechanical engineering stuff. No GEs, because I said fuck it, we ball. Senior year me is gonna hate me for not taking more of my GEs, but fuck them, because fuck him, because I get priority registration when I'm a senior and it's easy to get into them. So I'm trying to take all my major classes that I need to take that are prereqs. So I'm taking like a design philosophy class, I'm taking SolidWorks 2 Boogaloo, it's harder now. I'm taking... I taught engineering data. Guys, you're not gonna believe this. I am not taking a math. I couldn't get into a math. What am I gonna do? What am I gonna do without a math? I don't know what I'm gonna do. I have statics, which is like physics, but like not physics. But I don't have math. I'm so sad. And the thing is, after my next math class, I don't have any more math to take. What the fuck am I supposed to do? It's okay, I'm gonna take a math minor and then I'm gonna take more math courses. I really want to take up to vector analysis. Vector analysis is so useful. You can do my math for me, it's like another math class for you. I'm down to do it on stream if it's fun. I mean, if you ever have problems with it, feel free to come on and just yell at me and then I'll explain them. Let me try and remember. Okay, if we have two eigenvalues that are the same, if it's gonna look like a weird spiral galaxy thing. And it's gonna be called a degenerate node. It's gonna be called the pervert node, actually. This is the too horny. This is the shitty node. This is the dog shit awful node. To go along with the dog shit awful defective matrix. The pervert node. I'm gonna remember that and I'm gonna start laughing on my fucking final tomorrow and be like, I'm gonna be like, the pervert node. I'm really tired, can't tell. Does anyone remind you of the dog shit awful node? No, I haven't met any. I haven't met any defective. This is so specific. Like, I'm not gonna go up to someone and be like, yeah, you're actually a defective 2x2 matrix with a eigenvalue of multiplicity 2. Sorry, algebraic multiplicity 2. That'd be fucked of me. Okay, if it's pure imaginary, it is a... What is it called? It's called something like angelic, like the fancy point. It's not a node. I can't look at it. I'm looking away. I'm looking at chat. I can see you doing that in a way. What is it called? Fuck. Fuck, what's it called? Proper node. Okay, I looked at it. I looked at the chat. I cheated. It's a proper node. Okay, this is the virgin node, the virgin and the whore, the Virgin Mary node. Damie late streams, Damie streams past 6 p.m. are like fucked. They're like only ever gonna be like an hour, and like I'm just gonna say the most random shit on stream. Okay, so we got the regular nodes, which are just the real ones. We got the multiplicity nodes, which are the pervert ones, the degenerate ones. And then we have the proper nodes, which are the imaginary ones. Only real ones know. The imaginary proper nodes. Can't ever attain it, but we're always striving for that. And then if we have complex, we get some kind of circle, which is a stable spiral. Sorry, stable center, not stable spiral. Okay, stable center, and then stable spiral point or unstable. So okay, just a quick recap. We've got the reals, which are saddle point. What if someone did this to you? What do you mean? What if somebody changed me from a defective matrix? This is my drawing of me, by the way. What would my 2x2 matrix be? Oh, guys, personality test. What would your 2x2 matrix be? My 2x2 matrix would be... Oh, it's gotta have 8s in there. I think it would be something like... Okay, wait, what would my... No, okay, my repetitive... My lambda would be 8. So I would have 2 8 lambdas, which means I would be a unstable node. Personality test, what would you guys be? I'd be an unstable node. And that means my matrix would have to look like x squared minus 16x plus 8? No, plus 16x plus 8. So we need, like, 2 things. I feel like I might just straight up be diagonalized, guys. I'm not gonna lie. I think I'd be You know where Drum is like, I think I'd be a rat. I think I'd be a rat. Me, but I think I'd be diagonalized, guys. I think I'd be diagonalized. King of the vectors, but still cool and with it. That's me. Rev, I think you would be... what lambda would you be? What lambdas would you have? Just a little vector. Oh, what about egg? I feel like egg would have to have a lambda 0. Gonna be honest. At least 1. And then I feel like you would be like a 0, like I kind of guy. That's not actually even possible. I lied about that. No, you know what? I could see you as like a... as like a 3 plus minus I. Is that crazy? And then Rev? Rev is like, So that means you would be a unstable spiral point. I think. Egg, if I'm right about that. Yeah, because it's all based off of A, not B. I don't know, Rev. I feel like you would maybe be like... Oh, you know what? I feel like you would be like a 4 and like a 2. No. I lied. Like a negative 4 and a negative 2. So that would be a stable... That'd be a stable node. Yeah, negative. Is that an accurate vibe check? What do you think? 0 and I'm blazing it? You can't be a 3D matrix? You can't, but then I have to put you in 3D and then it's way too hard to draw you. Add a 0 and I'm blazing it. That's so true. Okay, so reals we have saddle point, we have stable / unstable. My tablet's pooping it. Stable node. And imaginary, pure. I'm just writing shit. I'm just scribbling. Pure node. I don't know if this is an accurate assessment. I can't add. This is what a stable node looks like. This one right here. What do you think? Sorry, let me like this one. And then egg was not on here. Egg is over here. Egg is this one. I think it kind of looked like that. Branching. Yeah. You're condensing down into a point though. Sorry about that. So you have imaginary, pure, oh, defective is the horny ones. Degenerate. Stable. You know, he's definitely not gonna put these on here. I'm gonna be honest. He's gonna like splitting in twain forever. No, you're forming in twain forever. If you were unstable, you'd be splitting in twain forever. He's just straight up not gonna put this on here. He's gonna put a fucking Romeo and Juliet one on here, and I'm gonna be like, dude, why did I study all these? And why did I draw these little things? Anyway. He just loves complex numbers so much. I see. Learning. So true. Complex, we can have stable center. Or... Okay, I'll show you guys the Romeo and Juliet one. Professor bullies the nerd. Stable / unstable. He taught at Harvard. He's a good professor. He's just like... He puts a lot of complex numbers on things. Stable / unstable spiral point. Okay, so Romeo and Juliet is like a really easy little example. It's basically just that x prime equals y, and that y prime equals negative x. So, it's supposed to be like Romeo's love, like, increases, like, with Juliet's love, but, like, they increase, like, in the opposite direction. So, like, the more Juliet hates Romeo, the more Romeo loves Juliet. Or you can think of it as, like, a predator-prey. So, like, the closer the predator gets, like, the farther away the prey gets, like, in the opposite direction. It sounds toxic. Yeah, it is. And we can look at it and see that it's toxic. So if we do this, we get 0, 1, negative 1, 0. And I think I fucked up the way to define this. Is that right, actually? Because this will be x squared plus 0 plus 1. Yeah, so x squared equals negative 1, so x equals plus or minus I. So just from this, we can see that it's not pure imaginary. So this, even though it seems like it should be pure imaginary, it's not, because pure imaginary means that this is like an identity matrix, and this is definitely not an identity matrix. So this is going to be the A plus or minus BI type. An egg, actually. You'll see in a second. Okay, so we can draw it because we know what it is already. Because it's plus or minus I, will have circles. So this is a stable center. We're actually going to have two different circles, right? So we'll have one that's representing like the plus I and one that's representing the minus I. I lied. This is not actually kind of like the egg situation. I thought it was going to be a spiral, but then I was like, no, that's not actually what this turns out to be. So if we plug these in, we'll get, let's just plug in lambda equals minus I. I wrote I. I guess we're doing I. So we plug it in. And we'll get out negative ix equals negative y. Who is this to you? What kind of person is this? This is not a very good person. This is a... Well, so this specific one, I think that having a stable center is not necessarily a bad thing, but like it kind of implies that like you can't grow. Like essentially what it'll look like is, and we can kind of go through it and like do this. This is actually a good problem to do. So we'll get ix equals y. So that means that our value will look like right, 1 and then I. And with our conjugate, we'll have to do 1 and minus I, right? So we'll get y equals c1 e to the I t times 1I plus c2 e to the minus it times 1 minus I. And then we need to split these into their real and complex parts so that we can draw the real parts. So this will be e to the it is cosine t plus I sine t. And then we'll multiply this by 1, 0 plus I, 0, 1. So I'm going to fast forward just a little bit. We're going to get cosine. I just care about the real one for now. So for real, we'll get cosine t on the top here, just by foiling. And then negative sine t. And then for the imaginary, we'll get sine t up on the top and cosine t times I. So to draw this, right, we'll draw for t equals 0, cosine will equal 1, and sine will equal 0. So this one will start here. And then as we go to pi over 2, cosine goes to 0, and sine goes to negative 1. So it actually goes down here. So this makes a circle. Wow, that is a bad circle. Holy moly. So this one goes like this. And this is the real. And then the imaginary starts with sine t. So this will start at... oh shit, wait a second. Did I lie about that? No. That's right. That's right, I'm pretty sure. Yes. So cosine t, so it'll start here. And then it'll go... Wow, my computer is not having a day of it. It'll go this way. So this is the imaginary. So the reason why I say this is like not a very good person, if I were to describe this, like I don't think I've met some people like this, but essentially like once you put a t into this, right? Once you, sorry, not even a t, once you like put constants into this, because these will have constants out in front times like a constant. Once you put those constants in, you've defined this system forever. Like if those constants don't change. So you're kind of just stuck, like recursing in this cycle. And it's, you know, maybe it's like just you keep falling back from any possible growth you could get, or maybe it's just like your relationship with like where you want to be and how you just can't ever attain it, but it's just kind of sad, really. But it's a nice system. I mean, like, circles are nice. Which is a funny way to think about it. But me, oh yeah, this is a cycle of, it's an Ouroboros situation. But you know, circles are nice, so fucking it's good in engineering or in like applications because it's a system that is continuous, right? Like it'll continually keep going. But to be honest, a lot of these models, like, a lot of these models would not be very good people to be, because, and to be truthful, when I was assigning, like, eigenvalues to, like, you guys as, like, a funny joke, it's like, I think of more, like, numbers that would be eigenvectors to you. Or eigenvalues to you, more so than I'm thinking of like what the outcome is, which is why I thought it would be fun to like do the phase portraits for them as well, because I chose eigenvalues without thinking about like, oh, do I think you'd be a stable center, do I think you'd be an unstable spiral point, or do I think you'd be like a degenerate node, you know, stuff like that. I think it's infinitely more interesting and like kind of more truthful to like think about it the other way. It's kind of like a horoscope, I guess. Like, the horoscope isn't really determined by you as a person. It's, like, determined when you're born. I like -420. Makes me feel like an evil weed. It also makes you stable. For better or worse. You could argue that stable things are worse because it's, like, you don't grow. But you could argue that unstable things are also bad because you'll never attain anything, and you'll always just keep growing forever. Both are kind of hell in their own way. This is a fucking philosophy stream now, actually. Capitalism. Real. Truth. Capitalism is a degenerate point. An unstable degenerate point, everybody. Log spirals, baby. All the way down. I actually don't know if degenerate nodes reach infinity faster than spirals. Kind of an interesting question. I think they reach at the same time though, because they both have e to the t in them. Or actually, wait, they might not. They wouldn't. Oh my gosh, the degenerates points would reach it faster because they have a t e to the t, so they're getting that extra boost. Wild. Anyway, let's do an undetermined coefficients, and then I'm gonna do some, I don't know, we could do some fun physics. Helping you study by driving you insane. Oh my gosh, did someone follow right now? Thank you for the follow. Oh, this is like my most insane stream I've done in a while. Thank you, Kalma. Wait, K Maltaz. Okay, I don't know. Mal. Hey. Why were there like? There's so many people here, listening to me talk about this. Someone just texted me and said, "Wouldn't the proper nodes correspond to real eigenvalues instead of pure imaginary?" I don't think bro knows what he's talking about. Sorry, dude. He's very smart. I shouldn't say that. No one here is from my fucking Discord. Guys, what if one of my viewers was like, what if one of my viewers was my professor secretly? He comes on, he's like, "Oh, dude, got your stream last night. I really think your discussion of the degeneracy of different phase portraits and how they relate to the philosophy of people are really interesting." I feel like he'd be into the philosophical discussion, not gonna lie. He's a philosophical dude. Let's do a method of undetermined coefficients, why don't we? What's a good one? I don't know. They're all kind of long, but like let's just do one for the funsies, you know? I think that's in differential systems. Maybe not. Actually, I have some up in here. Why would I do anything other than the ones that are here? I don't know why. I don't know why. I was thinking that. Week... What is this? Wait, why does it say week 7? It's not week... Oh, maybe it is week 7. Maybe I just typed it wrong. Yep, we're diagonalizing to find different things. Oh boy. More diagonalization. Where's like my week 9 at? Oh, I just called it week 9. I didn't even bother with the rest of it. Where's the undetermined coefficients at? Here we go, week 10. Hi, what year am I? I am just finishing up my first year of undergrad. This is like, I don't know. So this course is called linear analysis, which is basically just a combination of linear algebra and differential equations. Sorry, I spoke really fast there. It's a combination of linear algebra and differential equations, but the way I like to think of it is linear algebra for solving differential equations, because the end goal is really to apply it. It's not really to learn the linear algebra. So let me do a little undetermined coefficients here. Where was I going with this? This is a good one. No, it's not, actually. I lied. Oh, God. I really hope he doesn't put these on there. I don't think he will. But these, like, these ones, these type... I know you guys couldn't see that for a second. They are kind of brutal. Oh, I forgot about this! Sorry for blasting your ears. I made this and turned this in on my homework. Here's where I'd put A and B if I had... I was trying to solve these and I just could not solve these problems, dude. Okay, like this one's a good one. Let's do this one. So d squared plus 6d plus 10. I'm just gonna actually copy it. Sorry, I'm just laughing about that. No, it's the wrong thing. Wait, it didn't copy it? Oh, man. Okay, what was it? 6d squared plus 6d plus 10? d squared plus 6d plus 10 equals cosine omega t. Omega t, guys. 6d, no way. Guilty Gear reference? So based. Okay. Time to find eigenvalues first. Wait, what do I... Yes, we're solving the general solution. Hee hee. Sorry, we're not finding eigenvalues. What the fuck am I talking about? We're finding yp, yh. Oh dear god, I'm gonna fail this. Okay, factoring time. Okay, everybody. Fun little quiz. How do we factor? How do we factor this? How do we factor this? Any answers? Any takers? I'll give you a hint. Starts with negative. -6. You don't. Potato. Rev, you're actually kind of right. You don't factor it. It's the quadratic formula. Negative b plus or minus square root b squared minus 4ac 36 minus 40 over 2. If I ever did a cover of a song, it would be of the quadratic formula song. It'd be Damie's first album cover, and it would just be a picture of me holding a parabola, meeting a guy on the street with a parabola in his hand. And he looks so sad. He has a parabola in his hand. He says, "Sir, can you please help me? I don't understand this. If I could explain it, this problems all the brain." Whatever, how the song goes. It's the only quadratic formula song I'll ever know. Anyway. -3 plus or minus 2i. If we were trying to graph this, this would be a stable spiral point, just for fun. Is that the song where the guy got killed? Yes. I got killed. Remember, this was the Damie lore. He stabbed a knife into my brain. Maybe he stabbed the parabola into his brain, actually. Sorry. I'm insane about this song. I think about this song, like, a lot, because I do the quadratic formula, like, a fair amount, and I legitimately do remember it based off of this murder song, so... It, you know, not a lot of people know it. Really glad, Now I'm a math angle. I should just, like, misspell. I should just misspell angel in my thing. So that it's angle. Okay, why do I keep writing YH? Why? It is YH, fuck me. Okay, C1 e to the -3 plus 2i times t plus C2 e to the -3 minus 2i times t. Okay, good first step. Now we have to choose an annihilator. Absolutely normal things to say in math. We're gonna choose d squared plus omega squared. Which kind of sucks, but it's what it annihilates. It needs to annihilate with this. So now we need to multiply. No! Okay, this is gonna be really hard, actually. No, it's not. Do I think I can just pull this off? I'm gonna go ahead and say yes. So what we're gonna do is, instead of multiplying it out, because they are different things, I'm just gonna say this. And now I know what you're thinking. You're saying, Damie, how dare you? You can't just set the annihilator equal to 0. That's illegal. That's literally illegal. And here's what I say to you. Yeah, it is. It might not work, but I think it'll work. You trust me. So d equals negative omega squared. So that means d equals plus or minus omega. Evil mode? Can I... My evil mode is so bad on this one. I feel like I'm so emo. What if I just, like... Where's my thing? That's not it. Here, what if I did a pog instead? This is my permanent pog face. Have I showed this off? This is just pog. It's just pog is my face. I actually can't get... Wait, I can be white? Wait a second. I didn't oh my god, I could be white, guys! I look so scared. I'm gonna be white instead, sorry. Was this... up. I am incredibly sorry, new viewer. I will pay you money. I am so sorry. I need to put a massive warrant. I legitimately should not stream like this. Guys, okay, I'm gonna be really honest. If I put a goal for me to buy a USB hub that doesn't power limit my computer and blow up my mic so that I can stream without blowing up people's ears, would you guys, like, help me get that? I could just buy one and say it's like a work expense, because I feel like at this point it literally is. I'm so sorry. Let me answer your question. What are my favorite resources to learn Physics 2 and differential equations in linear algebra? Okay, this is a great question because I actually have great answers for you. Gilbert Strong. Gilbert Strong. Amazing teacher. Amazing guy. He wrote a book. He wrote a wonderful, wonderful book. He also has video lectures online. He, I think, is like one of the best guys to learn linear algebra, specifically. I don't know if he actually gets into the differential equations because I mostly know him for linear algebra, but Gilbert Strong, incredible. Look him up. He just retired recently, actually. He's a little old now. And then for Physics 2 electromagnetism, I'm actually currently doing that and having, oh god, a time with it. But there is this one book, I don't know at what level you are learning it, but it's a pretty good book, I think. I've been reading it and I'm actually probably gonna stream learning it more over the summer and trying to actually do it. It is, what is it called? Who wrote it? Electrostatics is, where is it in? I think I saved it in textbooks. David Griffith. So David J. Griffith. E&M. And this is linear algebra. This is like at a, this is like if you know vector calculus a little bit. Yeah, it's really good. I think it's actually pretty, it's not even that bad to like read as a textbook. I find some textbooks are very hard to read. And then I'm trying to think. Oh, one other really good thing is 3 Blue, 1 Brown. You probably know him already if you've been looking for linear algebra resources, but linear, I think he does some differential equations as well. Lots of like great visualizations. Really awesome stuff. Yeah. But yeah, I would definitely recommend Gilbert Strong for linear if you haven't looked at him already. And then honestly, not to toot my own horn, but I do have some pretty decent streams with examples that are going to be going up over the summer on my YouTube. If you're interested in just like having some problems and like having somebody talk through how he does them. Because I have a whole bunch of linear content. I also have, I don't know if I have my old linear content, but I took linear algebra specifically before taking linear analysis. I actually did stream at that time, but I don't remember if I saved those VODs or not, so those may not exist, but yeah. I do have a YouTube channel. I am actually going, so to give you an exact date, I hope you don't have a deadline that's like, I have a final tomorrow, because the VODs won't be uploaded by then. But my YouTube is, let me pop that in chat for you. My YouTube is this. And if you're interested in, I was gonna go through my whole ass VOD backlog and like upload one every day. But if you're interested in the linear stuff specifically, I might just upload them all privately and then make a private playlist if you would like to use them as resources. I actually did a VOD, my VOD from yesterday, where I started doing like a very, 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 very speed run version of like a lot of linear algebra stuff. Which isn't very good, but if you're just looking to like get into it, if you haven't started learning it, it might be kind of fun to just like listen to, and if not, then like that's totally fine because I literally didn't write lecture plans for it. But yeah, and then I'm doing some differential right now, but this is all like I will be doing more differential. Oh god, sometime next year. I know that's like literally not useful if you're in school right now, but I'm a mechanical engineer, so it's all like kind of applied differential equations, or like not applied necessarily, but like more specifically suited to engineering applications. Okay. So these are our other little solutions here. This is, so our yp is going to equal c1, or we'll call it like a, e to the omega t plus b e to the negative omega t. I'm a good dude. Aw, you're so kind. I really, really wish that I could be doing lectures already. And I have so many ideas for like shorts. I'm gonna be honest, guys, I have so many ideas for shorts. Like just little like minute long things that like I feel like people would Google and like that they'd like an answer to with like a decent explanation that doesn't like turn into like a 15-minute video on like whatever topic. And I'm really excited to start doing those. I'm just like a little, I'm not stream shy, like I'm very confident like talking on stream and stuff, but like recording and like not talking to people, like recording with a script or something is like scary to me, even though I was an actor. And I like acting a lot. It's like, I don't know, it feels weird. So that's really the only reason that I haven't done those yet. So hopefully I'll get to do those sometime soon. E omega t plus minus omega b e to the negative yp double prime. I don't think this is gonna work, I'm realizing. But I also really don't want to multiply this whole thing out. Because like, how do you factor that? I guess you don't really have to factor it. You kind of just... Right? No, you do have to factor it though. What the hell? We should try it. I need to do one of these that's actually real, that I don't fuck up. My rate of success on these problems is very low, guys. I don't know how to tell you how low it is on these. Okay, so this will be d to the 4th plus 6d cubed plus 10d squared plus d squared omega plus... This also seems too hard, though. Oh, wait. Am I just supposed to factor the annihilator? Maybe I don't do this one. This one, like, seems like kind of hard. Oh no, this is how it starts. This is how it starts. If I can do one of these problems even, that's physics, then I can be out of this hell. What is this from? This is from 8.6? Okay, let's do 8.6. Oh shit, look. Oh, I can actually go to 8.6. Beautiful. Let's also maybe do one that has an answer that I can check. Okay. But they're all in RLC circuits, so like... What the hell is that? Oh, that's not like a proving problem. Let's do 5. Okay. Chat, I'm gonna go until I can get one of these problems. I don't want to delete the little parabola guy. That's cute. I should keep that up. I'm determined. I'm so determined. This is the last thing I need to do. Okay. R equals 16 ohms. 8 H and C equals 1 over 40 farads. God, that's a large capacitor. And then E equals 17 cos 2t. Okay, so our little formula for RLC circuits is up here somewhere. So it's y, so it's d squared, y double prime, plus r over l, so 2 d, plus 1, 1 over L times C. So L times C is LC equals 8 over 40 equals 4 over 20. Hey, baby! And then if we flip that, that's going to be 5. Equals 1 over L. Okay, so 17 over 8. You know, really great numbers that this book gives to us here. Okay, chat. Okay. It's gonna be complex. So we're looking for D equals something. So this will be -2 plus or minus the square root of 4 minus 20 over 2. This will be -1 plus or minus. So this is going to be 4i, but it'll be 2i, right? Because divided by 2. We've got that. So we can solve for YH. YH is going to be 1 CE to the... plus C2E to the -1 plus or minus 2IT. And I feel like we should probably... Oh, I don't know why I wrote it like that exactly. That's kind of cringe. But I feel like we should write it out like C1 times cosine. C1 times e to the -1, or minus t, cosine of 2t, minus I sine C2 e to the -t times times cosine minus t minus I sine minus 2t. So if we were to factor this, does this even matter? I don't think it really matters at this point, because we need to just choose an annihilator. Let's just choose an annihilator up here. This is going to be d squared plus 4, right? Because the inside term, this is our a, and that'll be squared. So we do need to multiply this out. So d to the 4th plus 2d cubed plus 5d squared plus 4d squared plus 8d plus 20. Kind of cringe. 9d. What is this? How do I solve this? Like, how am I just supposed to pull solutions out of my ass to this? What am I supposed to do with this, chat? Like, factoring. Can I factor by grouping? Not really, because there's 5 terms. What about... If I factor a d... Nope, that's not gonna work. And this is where I get stuck forever. Okay, you know what? Let's... I need to just be able to do one of these. Let me see if I have a better example. Let me see if I have an easier example than the book. I'm not gonna lie, the book kind of gives some bad examples sometimes. This is not copium, okay, chat? I swear it's not copium. It's not copium, I swear. Let's pick... Oh, I just crunched something. And of course, it's a little copium. It's a little copium, okay? Guys, I'm not good at math, I swear. I just stream it for, like, you know, hours a month. These are real stunts attempted here, folks, live. I love how I can get to that point and then I just can't factor it. I love math. I love math so much. I could easily factor that using a factoring calculator, but because I have to take a test with a pencil and paper, they don't let me fucking factor it. They're the real they're the real copers. Okay. Let me try writing as y prime instead. Maybe it'll like me more if I write it as y prime. Okay, look at this. Look at this annihilator. This is so much easier. Okay. And this one factors too. Oh, chat, bless our stars. Okay, d squared, I have to immediately change it into the other form. Plus 3d plus 2 equals 0. This will be d minus 1 plus 1, d plus 2. d equals minus 1, d equals minus 2. Oh, beautiful. Oh, it's beautiful. Anyway. This would be a stable node. Just categorizing everything. It's like this isn't even a linear system. Well, we can turn it into a linear system, but we're not going to talk about that. Okay. What do we do? Oh, annihilator. This is just gonna be d squared. Oh, beautiful. Look at this chat. Oh, it's so beautiful. Okay, so then d squared equals 0. d equals minus 1. d equals minus 2. Oh, I forgot to write yh. Oh, so beautiful. Okay, so this is gonna be c1 times e to the 0t. That's gonna be c1 plus tc2. Okay, beautiful. Let's not use c, let's use a and b. Okay, so yp. Look at that, it's so beautiful. It's so small and little and beautiful. Okay, we take the first derivative. Look at this little baby. Oh my gosh, it just goes to b. B for baby. And then we take the second derivative and look what it does. It goes to 1. Oh, it's so beautiful. Okay, so then we do 1 plus 3b plus 2a plus 2bt equals 3t plus 1. So 2a plus 3b plus 1 equals 1. And 2bt equals 3t. So b has to equal 3 halves. And if let's see, so we do this. This will be 0, right? So 2a equals minus 3b. A equals minus 3 halves b. So minus 3 halves times 3 halves equals minus 9 fourths. Look, chat, we did it. We got an A and a B. Uh-oh, wait a second, did I do that wrong? I might have done that wrong. Wait, shit, the derivative of a constant isn't 1, it's 0. Who let me do this? There we go. So this is, plus 1. So A is, let's see. So minus 3b plus 1 is going to be 9 halves, or yeah, minus 9 halves plus 1, so it'll be minus 7 halves, so minus 7 fourths. So negative function is just to negate the negative sign integer? Yeah, it sounds like that would be the case. For C++? Let's see. Let's see. Yeah. Ooh, times -1. Oh, wait, yeah, why would you need to do that? Is there a negate function? I guess. Oh, is it for an array? Yeah, that makes sense. Yeah, for an array, it looks like it just negates it. Not sure if that's like a in place function or not. Okay, now we can finally write y equals no yc, no yh, no yp. Chat, we just get to write y. And then we get to write c1 e to the minus t plus c2 e to the minus 2t plus 3/2, wait, minus 7/4 plus 3/2 t. That's so beautiful. It's so beautiful, chat. It's so beautiful. The one method of undetermined coefficients problem I've ever solved. No, it's okay. We can do another one. I'll just do one more. I should probably do one with like sine and cosine, because it's probably gonna be a sine and cosine one, but oh wait, actually there's a quiz that I have that had a sine and cosine on it, I think. Oh shit, I could actually probably look for it in my pile. Don't ask about my pile. Oh wait, no, I just have it written down. I don't need to look for it in my pile. And then we're gonna do some chem. We're gonna do chem. Because, you know what? I can be a little vulnerable as a treat, okay? You guys can get to see me do chem, which wait, it's literally been here the whole time. For a moment. I had these. I literally had these whole I thought I didn't have these quizzes, and then I had them. That's really funny. They were just hiding behind The Extraordinary SVD, a paper by Carla D. Martin and Mason A. Porter, a great paper to read about singular value decomposition, which is one really awesome application of linear algebra, and is probably the largest mathematical achievement we've made in the last recent history. Anyway, I can't teach that to you guys, because I'd have to teach you linear algebra first. Maybe one day I will do a video on singular value decomposition. Okay, chat, we need to be able to do this problem. This one right here. Okay? If we can do this, we stay winning. Okay, d squared plus 4 equals 0. D equals plus or minus 2i. Okay, we're winning. We're winning so far. YH equals C1 e to the negative 2i t plus C2 e to the 2t. This is how my brain is like when I'm doing exams. I'm so like relaxed and like laid back on stream, but like when I do exams, I'm like okay, so I can write that as C1 e to the so cosine cosine negative 2t plus I sine negative 2t plus C2 cosine 2t plus I sine 2t. And then we need our annihilator, which is going to be, so this is going to be A of D equals d squared plus 4. We get multiplicity 2, d squared plus 4 squared equals 0. So we'll get, oh boy, so we'll get our first ones, which will be A e to the 2it. And then ct e to the 2it. d t e to the negative 2it. And we know these are in our other one. So yp equals ct to the e. So okay, we're gonna factor out the c, or sorry, the t, and the e to the I. No, I don't want to do that. We're just gonna do that. So c, and this will then be cosine 2it plus, sorry, cosine 2t plus I sine 2t plus d cos negative 2t plus I. Okay. We have to take the derivatives of these. Needless to say, I kind of don't want to do that. Is there a faster way to do this? Let me think. Okay, I will say, one thing I really want to be able to do is do c plus d cosine 2t. Because cosine is an even function, so cosine of 2t equals cosine of negative 2t. And then I really want to be able to say plus I, nothing. I don't want to say anything else. Because sine is not an even function, so you take this out, and then that would subtract it. Oh shit, so that would be plus c minus d. Sorry, I sine 2t. We'll try that. I think I tried this before and it didn't work because I didn't have this part. Okay, so if we take the derivative of this, that'll be c plus d. Negative times negative 2 sine 2t plus... Oh shit, I forgot about the t's. I'm just gonna slap the t's on here. God damn it. God damn it, guys. God. It's fine. This is kind of right still. It's not right. Don't listen to me. C plus d cos 2t. And then we want to do the other derivative, so that'll be plus c plus d and minus 2 sine 2t. And then for this one, this will be c minus d. And then plus c minus d. Okay, now everybody's favorite time, when we get to write 8 functions out. After hours, Damie just hates math, actually. No, I'm kidding. I like math. This is just tedious. Okay. Plus, and then another product rule. So this will be C plus D. Okay, nice. These will go together. And then plus C plus D T times minus 4 cosine 2t. And we're not done yet. Plus This is just a normal dude, so we'll get c minus d I cos 2t 2i. Everybody having a good time? C minus D I 2 cos 2t plus C minus D IT times minus 4 sine 2t. Okay, so this and this go together. Now we have to add all these up, by the way. Is there anything else that can go together? Not really. There should be some cosines that go together, actually. Yeah, this one and this one. So this one and this one go together, this one and this one go together. So we'll just have 4 terms. You know, just 4 terms. Now we have to plug it into this. So y double prime plus 4y. So we don't even need y prime. So minus 4 sine 2t plus c plus d t times minus 4 cos 2t plus 4i c minus d cos 2t plus c minus d it times negative 4 sine 2t. Everybody catch that? And then plus 4 of just y. So that's plus 4 of that. Plus 4 t c. What's the better way to do this? Oh, I can do that. Yes, plus 4 t c plus d cos t plus 4 c minus d I sine 2 t. I don't think I'm supposed to have an extra. Oh, I will. Do have an extra t. Okay, so the i's cancel out, I believe. Where's my other I for sine? I'm losing it. Yes, so this one cancels out, and this one cancels out. This one cancels out. Nope, I lied. Yes, this one cancels out, and this one cancels out. Okay, gamers, we're in the final stretch. We're doing it. Okay, minus 4 sine, I'm running out of room, 2t times c plus d plus 4i c minus d cos 2t. We look at the thing. Our answer is 8 sine 2t. So c plus d equals negative 2. And this is 0, so c minus d equals 0. We add these together. 2c equals negative 2. C equals negative 1. D equals... Sorry, C equals... Is that right? Negative 1? I don't know if that's right. No, that's not right. Fuck. C minus D equals 0. So D would have to be 1? I know for a fact that's not right. No, chat! I'm in shambles. I don't think I can, like, factor it out, that's why. I came so close. -1 and -1? It might, but I had 2 people who worked on this problem with me get, like, -2. Let me see if I can just plug the values into something. It should, yeah, -1 and -1 should work. But, like, it feels... Would that be right? I feel like I did something wrong. Oh, fuck. Okay, let's see if I have a... Thank you for the kind words, though. Also, welcome in for the first time. Oh, your name is Oreo. I used to go by Oreo online. Well, a long time ago. What can I even put this into? I guess... General... Solution? Calculator? Ordinary differential? Non-homogeneous? Eight sine 2t. It's such a simple equation, and like, yet it is so... What class is this for? This is for linear analysis, or like linear algebra, basically to solve differential equations. Okay, the answer is supposed to be c1 cosine 2t plus c2 sine 2t minus 2t cosine 2t. So that is not right. Darn it. I think it's because I don't think you can do what I did with this, which is strange to me why you can't, because cosine is an odd function. So like cosine of 2t and cosine of negative 2t, you should be able to combine them, right? Into this? Unless I'm like silly. And for this, it should be I sine, and then like, unless I made a math mistake, but it's actually pretty unlikely I made a math mistake because I made it all the way down here. Yeah, so minus 4, so c plus d should equal minus 2, that's right. And c minus d should equal 0. If you add these, 2c equals negative 2. Oh, that's a shame. Shame I got through all that and still wrong. Well, you win some, you lose some. I wouldn't want to have to go through this whole thing. I think it's because I sine... Wait, isn't sine an odd function, though? Because I pulled out a negative. Like, I did I sine of negative 2t equals negative I sine 2t. That's what I ended up doing. I'd be thrilled if it was a mistake in, like, this, because then that means... Yeah, then that means I could, like, fix this, and then it'd be right. Because originally what I thought was, oh, if you had this, then, like, it would end up as 2 cosine 2t, and then the signs would cancel. Yeah, no worries, no worries. It's a little thing, because I didn't actually write it out. I just said it and out loud, and, like, obviously you weren't here for that. But I kind of wonder why it wouldn't work. Like, I wonder if there's another mistake somewhere. I'm trying to think, if it was a sign mistake, what if c plus d equaled positive 2 somehow? If that...
74 has been added to the class.
Oh, thank you for the follow. If it was positive 2, then we'd get 2c equals 1, or c equals 1, and then d would have to be still negative 1, and that's not right either. Huh. Very strange. Very, very strange to me. Let me stare at it just a little bit. Let's see if we can figure it out. Let me actually also just check. Let me do a little Google. Does cosine of minus x equal cos x? Yes. Does sine of x equal negative sine of x? Sorry, sine of negative x. Maybe I just can't do that for sine. But I think you can, right? It's an odd function. Oh, here we go. Sine of negative x will equal negative sine of x. Yeah. Huh. So with that, we would get c cosine 2t plus d cosine 2t. That's where we get the c plus d. And then ci sine 2t minus di sine 2t. And that all checks out. So those wouldn't go away. Unless it's actually like a 4. Hello. How's it going? Unless I have to use different constants for each of these. And that might be the case. Oh my gosh, thank you for the subscription. Holy shit. Brian. Holy shit, oh my god. Thank you so much. What the heck? I'm just a little cat boy doing math. Oh my gosh. I think, okay, maybe the big brain thing. Maybe all of them have to be different constants? Is that like too small brain? It's like 9:30. If I text in this, my exam is at like 7 a.m. tomorrow. I don't know if people, let me see if I can just text this one guy who finished that one problem. Oh no, he's offline. I'm gonna text him, he's gonna like text me tomorrow, he's gonna be like, sorry, I didn't see that, Damie. And I'll be like, fuck. Have the solution to... Oh, okay, I'm so confused, chat. What if I just like... I was trying this cool, awesome swag factoring technique, and I don't know where it failed me. Oh, I typed in emo at some point, apparently. Sorry, I turned emo for a second there. Well, shit, okay. That's disappointing to say the absolute least. But we did one. Chat, we did one method of undetermined coefficients. Sine and cosine continues to best me. I'm actually maybe 95% sure that this question is going to be on my exam verbatim. So it kind of really sucks that I don't know why this doesn't work. But we're gonna say, fuck it, we ball. We tried. I don't know how though, like why? Maybe I can, oh, show steps. Wait, what? Oh, it just says solve it. I don't think there's maybe Wolfram. Let's go to my good buddy Wolfram Alpha. My beautiful, beautiful friend Wolfram Alpha. Y plus 4y equals 8 sine 2t. It's gonna be like, what the hell are you talking about? Second order linear differential equation. Okay. Okay. Also, big win. I did call that it was gonna be an unstable spiral, and it is an unstable spiral. So they say that it is the same thing, but step-by-step solution? No! Wolfram Alpha Go Pro! How could you do this to me, Wolfram Alpha? Oh, can I 12-foot wall it? What do you think, guys? Can we 12-foot wall this? Or 12-foot ladder, whatever it's called? 12-foot ladder. Give me the paywall. Remove the paywall, please. Oh, we just removed the whole site. It's not gonna be able to work, I don't think. Oh, Wolfram Alpha, what if we do the inspect element Q? Can we turn off the GoPro button? Oh, fuck, man. Oh, that's so infuriating. Is there a way I can check this, like, easier? Derivative calculator. Okay, let's try that. I'm like running in tiny little crazy circles. Yeah, let me take you guys along for the journey with me. Where's my sources? Derivative calculator. Where is it? Oh, it's under that. Okay. Derivative calculator of... Oh, this is how we can check. Oh, big brain. Okay. I'm gonna put in like C1 cosine 2t plus I sine minus 2t. And we're gonna try like that. So A times cosine of 2t. Oh, 2x. So we'll do minus 2x plus I sine 2x minus 2x plus B. Check this out, chat. We're gonna see this, and then we're gonna get the second derivative of this and see if it's the same as the second derivative of what I got, and then we can figure it out. Assuming that this actually can do this, though. I have faith in derivativecalculator.com.net. This is a great site. Never once failed me. Okay, here we go. A little worried. It usually does okay with constants, I'm not gonna lie. Calculate next higher derivative. Okay. Minus 4 sine plus cosine. Did I get that? Minus I... Okay, wait a second, chat. Wait. Okay, we got minus 4. Oh, shit, so they had a minus... No, plus. So wait, so minus 4 times sine B minus A. Okay, that's the wrong way around. What? Uh-oh, wait a second. B minus A. B minus A. Wait, no, it's minus 4. So if we put it in, it'll be no, it won't. I'm copium. I'm literally copium right now. Okay, so well, okay, wait a second. Before we go crazy here, before I go crazy and be like, my answer is so wrong. Let's do the derivative of what I said it was, which would be... Oh, wait, I forgot the t's. Of course it'd be wrong. Wait a second, there's no t in there. It's supposed to be a times t. I think. Right? Because we had t times all of this, so that would be t. Okay, maybe. Big money. Let's fucking go. Okay. Calculate next higher... Okay. Also, I realized I could have done this in a little bit easier parts way. Negative 4t times b minus a. Okay, so it's still this, like, b minus a thing. Wait a second. Did I put the... sine minus 2t... Oh, I put that one in the I put that in the opposite order. This is supposed to be B, and this is supposed to be A. We're getting close. Chat. We're getting close. Maybe I did do this right. I would be so pleased. What? Wait, what? I think it's because B minus A negative, and they moved the negative from the sine minus 2t. Sorry. I'm fucking everything up. In my here we can look at it. In my version, I have the D on the negative. Wait, let's just put in D and C too. Okay, so this is the D. And this is the C. Uh-oh, I can't use D. What if I use capital D? We'll just use capital. Look at that. Okay. This is exactly what I have written. Oh, you can't see it? But like, So D minus, I'll show it in a sec. Wait, let me move my big fat head out of the way. Okay, you can see what I wrote? And I have that written here. Big money, big money. Big money, big money. Okay, calculate next higher derivative. Okay, 4t, d minus c, minus d minus c. Okay, d minus c sine and minus d minus c. Okay, somehow I just flipped the two. Like somewhere in here I flipped a sine and a cosine. Do you see that? Like this one on the left should be a cosine, I think, and this one on the right should be a sine. Okay. I really shouldn't be spending this much time on it, but like it's whatever, I don't care. It's worth it, I think. Because I really want to know if this works. Okay, so we do, okay, the first one we're taking the derivative of t, so we don't have to worry about the cosine. We're taking the derivative of cosine, which is sine. We're taking the derivative with respect to t, and then we switch it to cosine. Cool. We're taking the derivative of cosine, which is going to be switched to sine. Taking the derivative of t, which is just going to keep the sine, and then we go to cosine. This one will be cosine. This one is just t, and this one... Okay, so those all... Oh, you guys can't see. So those all line up. I checked all the sines and cosines. Now, it could be that there's a sign mishap. Which is probably also likely. So let's see. Okay, we're going from cosine right to cosine. So this is just the t. I'm sure this is fascinating to watch. Sorry. Or maybe it's exciting. And this one goes to this one. So we do get we pick up a negative here. Which is right. And then... Oh! No, I was gonna say I think I figured it out because I have to do the negative d, and that's not a thing. That's not a thing. I just keep it as constant. Don't listen to me. It's fine. I didn't even say anything. So this keeps that sign because it's just the t, and the t just goes away, and then this will keep the sign because it's going to cosine. We're cool. So this one will change signs. -2. Yes. This one will keep the sign. This one should keep the sign. This one keeps the sign. Wait a second. Wait a second, wait a second, wait a second. 1. 1. 1. 2. This should be sine. No, it shouldn't. It shouldn't. It shouldn't. It shouldn't. It shouldn't. I lied. That's fine. That's fine. That's fine. This is sine. Wait, what? Oh no, it's not. I lied again. This is cosine. It stays cosine. It keeps a sine, and then it changes sign. That's fine then. What the hell is wrong? Did I copy it down wrong? I mean, that's a possibility. So these two combine to be -4. Then this is -4. Then this is +4. I'm so confused. It seems like it's so right, is the thing. Like, how? I'm... Okay, well, maybe this is just one of those questions where we don't have an answer to it. I'm gonna... Oh, this guy texted me back. Wait, chat. Let's see if this guy comes in clutch. Oh, shit. I have to Sorry, that was a very loud exclamation of oh shit. Okay, I just don't want to do it out. I'm stubborn. I'm stubborn, chat, and I feel like the functions should work because they're functions. I should probably go to bed. Okay, we might have to call it. Wait, let me show this. Let's go through this. It's so big. It's so big. Look how big it is. Okay. Oh no, why did it scale like that? What the hell? I shouldn't have to scale it like this, but it's fine. Okay. Okay, t cosine, this one. This is the same thing that we had. Wait, no it's not, huh? Come on? What? Y equals A. What? Wait. Did I fuck up like at the very beginning? No, I did not. YH equals C1 this. Shama? So then why this is multiplicity 2, so it's 4 overall. Huh? Is it not 2 times everything? Well, this still doesn't figure out the case of how this answer doesn't equal the other one. Doesn't equal the factoring of the first one. Because it should be the same. But, okay, you know what? Okay, let's look through to see if I can see if this example was done in my notes somewhere. Chat, I'm in shambles. I'm coping so hard right now. Yes. Wait. Okay, so if I have YH equals oh, this is Bill's. Wait, is this Bill's lecture? Wait, this is Bill's lecture. No wonder why it's so good. I was like, wait a second, these are like really good values. Okay, we can't use Bill's lecture. Sorry, my man Bill is my favorite dude ever, but I can't use his lecture. I was like, hey, why is this trial solution so easy to do? Here we go. Okay, find YP for that. Okay, gamers, I think I'm just bad at math because it's not 2 different things. This is why late night damie streams don't happen that often. Oh boy, okay, it's only one thing, and so I did a bunch of extra work for no reason. It's literally just only 1 times of this cosine, so that's why that we're not getting the right answer. And also why all of the math is bad forever. And you know, that makes a lot of sense because this truly is just a linear combination of this. Like, we literally proved that this is a multiple of this. So, like, I'm not satisfied. That makes me so sad. That's so sad. This is not gonna be the last problem I do. You know what? We're not ending this problem until I get it. Oh, chat, we're not ending this problem until I get it. Okay, I'm gonna go to bed after this. I'm gonna go take a shower after this. So we're gonna roll up our sleeves and we're gonna finish this problem. This is the last, technically the last linear analysis problem I do on the stream. We're gonna do this damn thing right. Okay, our YP equals T cosine 2T minus I sine 2T y p prime equals cosine 2t minus I sine 2t plus t times derivative of that is negative 2 sine 2t minus t, no, I already wrote the t, minus 2i cos 2t. We're cooking with gas. We're cooking with gas, chat, with this new knowledge. With this new knowledge of bases, which I really should have thought of before, but we're not going to pay attention to that. We're going to pretend that it didn't happen. Okay, negative 2 sine 2t minus 2i cosine t plus minus 2 sine 2t minus 2i cosine 2t plus t times minus 4 cosine 2t plus I sine 2t. Okay, there we go. Let's cancel stuff off. 2 sine 2t, well, equals negative 4 sine 2t. So this and this and this and this. Negative 4 cosine 4i cosine 2t. And then plus, sorry, minus 4t cos 2t plus 4 ti sine 2t. Okay, we're getting there. Now this plus 4 of the original, 4t cosine 2t, that cancels and that cancels, minus 4 ti sine 2t, this cancels and this cancels, so we're left with equals minus 4 sine 2t minus 4, uh-oh, I forgot all the constants, chat. God damn it. Okay, A, B, A, B, A, B, A, B, A, B, A, B, A, B. Okay, we don't need to write any of the other ones down because all the other ones cancel out. 4A minus 4B cosine 2t. Good lord. Minus 4A equals 8. Minus 4b equals 0. A equals negative 2, b equals 0. Am I even how can you even be happy? Like, can you even be happy? Like, I thought it was so much harder than that. Like, this feels like I've tasted the nectar of the gods, and now I realize that it tastes like shit. How do I go back? How do I go back from the all-knowing cosmos? I don't know. I don't know what I can do. I guess I can write the general solution. Y equals all these years C1 e to the, I already forgot it. It was like minus, what was it? Minus 2t plus C2 e to the minus t minus 2 sine 2t. Happy and disappointed. Wait a second, wait, didn't it say it was cosine? Wait a second, uh-oh. Did it? Uh-oh. Oh, because we used in the first one. Don't listen to me. It's okay, it's cosine. It's actually cosine. We didn't fuck it up, chat. Happy, disappointed. Yeah. I was real. I'm still confused though how the other one didn't work out. That is still an unsolved mystery. Like, how did we not get that? cruel god. Fate has its masters and mistresses, and I am not one of them tonight. Well, I think that is a very fitting conclusion to send off linear analysis. Thank you everybody who stopped by stream. This is a little bit more crazy than how I normally stream. I'm a little bit more put together. But thank you so much for the sub, and thank you so much for the follows. Very glad to see new people. Normally I don't stream this late. Normally I stream earlier, and I'll be streaming even earlier because I'll be going back to EST soon. But yeah, expect lots of cool projects and stuff over the summer. Drown Him Friday, of course. We need a good Drown Him Friday. One last Drown Him Friday to send off the linear analysis. Really feeling the drowning spirit with this problem, not gonna lie. Got some lemonade. Egg would be mad at me for not using water, but... God. Glad I finished it, though. Glad we gave it the good send-off. I need to do one last thing before I end stream. We need to give it a proper send-off. How fitting. The PNG didn't work. Don't worry about it. Can I, linear burn? No, lighter color? Darker color. No, fuck. Divide. Fuck. Add saturation. No, don't lock the layer brightness. That's not good either. Oh, that's not good either. That's a little better. We need to give it a proper send-off. A Viking funeral, if you will. It's so beautiful. Look at the blue flames we've created. It's so happy to have some new food. No, just kidding. I would never burn this problem. It took me like 20 minutes to solve this. Half an hour. Okay, I'm gonna go shower. I will update my schedule. Also, I should probably post my new schedule link in my description, because I don't use the Twitch schedule. But this summer, I'm probably gonna be streaming 3 times a week. Probably like Monday, Thursday, Saturday, or something like that. I don't know, maybe like Tuesday, Thursday, Saturday. Some days. And I'll be doing some art. As well, and you know, a bunch of cool stuff, lots of engineering. I don't think I'm under like any sort of non-disclosure agreement for one of the engineering projects I'm working on, so I could maybe work on that on stream, because it is making me go a bit insane. My PLA is very moist, it is very thirsty, and it sucked up all of the water in my room, so I really need to dehydrate it because it's been messing with my prints, and I have no control over tolerances. Okay, I'm gonna keep talking if I keep streaming, so I will see you guys probably not this upcoming week, because I do have to get home. So you're gonna be damie-less for a little bit. It won't be... Oh shit. Maybe I will stream. Maybe I'll stream like Friday or something. I'll just do some Minecraft or do some Deep Rock, maybe. But thanks everybody. See y'all later. Have a good time. Love you all. Peace and love on the planet Earth, and remember to support your local degenerate nodes. They need hugs too. Okay, see ya.